Hello, hi. This is Anthony Bedone for a series called SQL in 10 Minutes, SQL ITM. And today we're going to discuss intelligent query processing. Let's get started right away. Hit the timer, boom, 10 minutes countdown. Okay, so first we'll get into the hierarchy of this whole process. And we'll just look at it and discuss it briefly. Don't forget, you can download all these diagrams. Okay, so do download all the diagrams and study the diagrams because that's where the information is. A diagram is worth a million words. Okay, so please download these guys. Okay, quickly. Uh, so I categorized all the different details within the intelligent query processing for us. Okay, so as you can see, it involves compatibility level 140, 150, SQL Server 2017-19, and the whole Azure environment as far as the database, SQL Azure database and managed instance. So the whole process is really to improve workload performance at runtime. Okay, and the process determines the runtime to be either compilation time or the actual runtime itself. So it's before execution time, rather. And it involves different categories of joins, memory, code, temp table storage, which are table variables, iterators, we'll talk about that, and count aggregates. So the IQP, right, intelligent query processing, and the functionalities, joins, memory, code, count aggregate, temp table storage, iterator get row. Okay, number one, the joins. Okay, it has to do with deferring the join selection of the hash or the nested loop. So if a query has decided to use a hash join and the optimizer decides that that's not the best selection, it'll bump it down to a nested loop. That's very, very good. Memory grants. Memory grants of course, is memory used for runtime execution of your queries. This process can grow or shrink your memory grant, which is a phenomenal process. So to avoid disk spillage, if we didn't assign enough memory for our memory grant and we're spilling to disk and using the disk as storage, it'll grow your memory and not do that. Or if you overestimate it and use too much memory, we'll shrink the memory and give it back to the system, back to the pool for other queries. Very, very good. Code, user-defined functions. The two functions are the multi-statement table value function, look it up, and the scalar function, look it up if you don't know those two. The two vehicles improve performance. One is called interleaved execution, and one is called scalar UDF inlining. The essence of these two guys is basically to improve performance. So as far as a multi-statement table value function, it will now use the actual cardinality of the returned table variable. Wow, that's great. Okay. The other one is the scalar function. The optimizer will actually take your code of that function and put it in line to the calling query. Okay, so it'll dramatically improve your performance. So that has to do with code, user functions, memory grants, joins, adaptive joins. Next, aggregate count. A little ditty where if you need to know the estimated count of a table and so forth, you can use this function here, approximate count distinct, and it'll immediately give you back a declared result without processing the information. So do use that if you need to be. Again, it's approximate. I have another category here, temp tables storage, and that really refers to the table variables. Here, as you see, the table variable deferred compilation. So the cardinality of the table variable will be deferred until compilation time and will then use the actual cardinality. Before that, the cardinality of a table variable was used to be 1, then maybe they changed it to 100, but that's totally inappropriate. Now it uses the actual table cardinality, so it can figure out a better plan for you. So again, joins, memory, code, count aggregate, table variables, and the iterator get. Little explanation. Every plan has iterators, the little functional areas that process your overall query, a join, an aggregate. Okay, and each right now, each little iterator uses a get row. It uses one row at a time, a single row to process. Also now there's something called a batch mode where you can actually iteratively use, it will switch from a single row to multiple rows for get. So you're getting multiple rows in one IO read, and obviously that's much quicker than a single row. So another performance. Before this was only for column stores, now it's for regular queries. Optimizer does that. Review, joins, memory, code, count aggregate, table variable, and iterator. Okay. Let's move on to a bit more of a description of that. Okay, that's kind of vague. Here's more details about the same functionality. So I'm bringing it up quickly, and then download this guy and do review it. I have to make it very large where you can see it, but it goes into a bit more detail about the things we just discussed. And I'll just get as large as I can here. Here we go again. So as you can see, intelligent query processing details, functionalities. We have joins. Let's talk about the joins. Remember we talked about the adaptive queries. Look to the right, execution time, determine whether to use a hash join or optimize and switch down to a nested loop, then continue with execution. So if the hash join is not appropriate, it'll knock it down to a nested loop and continue. That's called adaptive queries. Memory, the memory graphs, right? So initial state, runtime memory. So we have a declared runtime memory that we're going to use. Now we evaluate it. If there's spillage, okay, if it's going to disk during the processing, we're going to grow it. Wow. Okay, if we overestimate it and it's not being used, we're going to shrink it, take that memory, bring it back to the system for the other queries. The iterated get row. Okay, within a plan, every iterator reads your records. So as you can see here, the query plan is going to evaluate it, and we're either going to go for the get row is going to be rows or batch mode or one row. The optimizer does that for you. Behind the scenes, user-defined functions. Remember we talked about that? Interleave execution. Use the actual cardinality of the table variable, or if you're using the other time kind of function, we're going to take your code and put it inline in the calling query. Here, as we're going to use table variables and defer compilation and use the actual cardinality of the table. Cool. If you need some quick counts of table counts and so forth, you can use a statement called approximate count distinct. It'll give you an approximate count of the row counts. Boom, there we go. So what do? These are optimization features built in that kick in behind the scenes for 2017, 2019, and in the Azure platform. Okay, again, download these guys, my 2 screens, study them. It's comprehensive. These are all the functionalities built into the intelligent processing now, and do learn from that. Okay, so that was our series, and I see we spared it, and we have 3 minutes left. I'm going to say adieu, goodbye, and watch out for the next one. Take care. Bye.